So next up, we've got Michael Rampe, the CEO of Pedestal 3D, to speak about built-for-purpose 3D analysis tools integrated into the latest version of Pedestal 3D and latest breakthrough results of using the 6-axis photogrammetry method.
Okay, can everyone hear me? Can everyone hear me once is, I guess, the more important question. So I am here today on Darking Jung land. I pay my respects to elders past, present and emerging. I put forward 2 talks for this exhibition when Fred reached out to me. And one of them was this. So talking about Pedestal, spending 10 minutes going through some of the tool set and some of the specifics of the tool set for learning and teaching. As you can see there, I do a few things. So I'm the founder of Pedestal. I also work full-time at Macquarie University as a senior learning designer. Through that engagement, I'm a committee member of CAISH, and I'm a producer and consultant of Rampe realistic imaging as well. So it's a bit of a mouthful. I'm just conscious that, you know, in Eric's talk yesterday, in his keynote, that he spoke about not sharing data as some of these talks. I'm going to share every link I show you at the end. I'll paste it in the chat. Every single thing I show you today is open and public. So just to talk about Pedestal really briefly, we developed Pedestal over an early period, 2013 to 2016 at Macquarie Uni. It was really there as a tool to solve a job in education. We ran out of money in 2016, as you do at universities, the grants run out. So we sort of said 1.0 is done. A couple of years later, we spun it out as a company. And now we sell that into a bunch of markets, and we're currently working on a version 3 next year. So I can talk about that a bit more at the end. What's special about Pedestal? Like, in a way, we sort of pick up where Sketchfab leaves off. You know, when you need something more than just look at the 3D, you need to do analysis. So you need to do a scale, you need to interrogate things, measure, export data, do cross sections, screenshots, deal with multiple qualities. So there's a range of things to actually demonstrate today. But I also said I was going to do this 10-minute talk. So this is the other talk, actually wearing my Macquarie hat and wearing my Rampe realistic imaging hat, which is to talk about this photogrammetry method that I developed over the last few years. So the more I thought about it, why don't I just put the 2 talks together and we'll, you know, do both at once, and that'll be a bit of fun. So I can actually demonstrate Pedestal as I go through some examples from the method. So let's just get stuck into it for a second. So the Zoom overlays in the way, I think someone's telling me. I don't know how to fix that, unfortunately. I will come back to that in a second. The magician was mentioned in the panel this morning, and the magician should never show their tricks. So all of you are very lucky today because I'm going to talk about my tricks. This session is specifically about the technique of photogrammetry that I developed and how to get the most out of this, and then how to scale through that. So I just will drop out of this for a second and get all that stuff as much out of the way as I can. If I hide that, and if I go back in, that's probably as good as I think I'll get. So with that said, what not to do in object photogrammetry. A lot of people work on merging chunks, don't do it, it's rubbish, not accurate. They try and spend a lot of time getting clean shots with black backgrounds and white turntables. Again, too slow, too much hassle. You know, they think every object needs its own method. Well, it doesn't. We can standardize. Some people deal with automated turntables. I don't have time for that. Complex muckers, you don't need them anymore. Custom cradles where you prep how to hold an object. Again, too much hassle. So keep it simple for flip's sake is really my whole point on this process. And don't believe everything you read. You'll read a few tutorials on the web about how object photogrammetry works. At least half of them are either out of date or just plain wrong. So what is this method in an idealized way? We shoot loops of 32 photos. We shoot them angled down at 22.5 degrees. We shoot 6 of them, hence the 6-axis. So imagine you've got a dice and you shoot the object on each side of the dice, and only the object moves. The camera, the lights, everything else is stationary. So in a really simple way to look at this, one axis is this. You know, it's down at 22.5 degrees. You shoot 32 photos. You could make an object out of this in photogrammetry. Wouldn't be very good. There's only a single ring, so we're not seeing a whole side. And the maximum angular difference between cameras is 225 degrees. So it's not very good. We add an axis, something special happens. So if you turn that dice 90 degrees and take another ring, all of a sudden you've got these two overlap positions. So you've got these two camera positions that are shared between rings. And this is the secret to this method, because it absolutely means that those two rings will align to each other as you go through this. But you still got 135 degrees angular difference. It's not great. So you get to 4 axes. We're starting to get somewhere. You've got 128 photos now, 8 overlap positions, and 45 degrees, which is where we want to be. So, a lot less than 90. It's an acute angle that you can see every point on the surface of this object at an acute angle between cameras. And then, you add your final 2 axes and you end up with this wonderful shape, which is the idealized 6-axis camera rig that we end up with in photogrammetry. So yeah, a magic 24 overlap positions between rings. It just aligns, and it just aligns well. So how do you actually do it in software? It's a 2-pass thing. This is just a slide for those that want to know, but basically you automate the masking on each ring, and then you align those rings together with those masks. In really simple terms, that is it. I will not dwell on that. I want to show some stuff. So my setup, I use a 5D or an R5 now. This is arguably the best camera in the world. I don't want to argue. I use some flashes, so flash photography. I've got 10, about to have 12. Let's keep buying flashes. I'll get to that why a bit later. A lighting tent, so you get something like this. It's a big tent to put an object in to control lighting. You want a turntable, so a good old cheap IKEA turntable with some markers around the edge, 32 markers for those cameras. Pretty easy. I always shoot with a color checker, so a way to calibrate color. Color is important, especially with photogrammetry. Get some beanbags or blue tack or whatever you need to hold the object up, and then some software. And this actually method works in both Metashape and reality capture, depending on your preference. So what I'm going to go through now is I'm going to go through my top 10. So here's 10 objects that I did with this process in reverse order, aka Letterman, and let's go through them. So coming in at number 10 is the brick. I always start with bricks. Brick's the easiest, absolutely easiest thing to do with photogrammetry. It basically is a dice. So it sits on all the different angles. You can see the shape there that comes out of the software, and they're just wonderful things to be able to image. So here it is in Pedestal. So we've got this brick. We end up with really good quality that comes in. It's quite an interesting one. This one, if I turn off the color to interrogate this, people instantly think it says made in Japan. We actually don't know what it says because the J is not there, but people assume it's made in Japan. But just think for a second, why would we bring in a brick on a ship from Japan? Anyway, so that's object number 1. These are great, easy things to do in photogrammetry, and certainly get a really good result out of that. So coming in at number 9 is a rock. I've been doing a lot of rocks recently. You're going to see some rocks tomorrow in Nathan Dashko's talk. We've been doing capturing of head samples. So this is during COVID. How do we teach geology? It's something that, physical object-based learning is absolutely huge in geology, being able to identify rocks, work on crystallography. And this has finally got to that level where Nathan, and I'll let him say it tomorrow, but it's getting to the point where we don't need the hand samples. Now we still do, of course, but I've been doing quite a few rocks. You see down there in the corner, the rock on my older turntable with some custom markers. You don't need them. That's just there mainly for laser scanning. And this rock was held up with blue tack that you wouldn't consider for most museum relics. So the rock. So here is that rock. This one especially was getting right down to fully accurate color. So being able to calibrate that color using the color chart to be able to get the actual colors of these rocks. And there's a whole set of 30 or 40 of these we did for a virtual field trip and for study. So that's this rock here. Let's jump back and keep it moving along. So number 8 is a bottle. Bottles, these are constant throughout heritage. We're dealing with finds like this. This one obviously came from the European, was imported into Australia and then found in a Parramatta collection. So this one only did 5 rings. There was no way I was going to try and balance this bottle on its on the neck. But you can see below that I did 4 rings the way I said, around using my bean bags to hold it up, and then just did 1 ring in the middle that you can see around here. So that actually gives you 5 rings for this bottle. And this bottle itself, if I jump over to that, so here it is. One really important thing, I'm just going to turn the smoothness that I turned on with Pedestal, so I'll turn that off. This method is really tolerant to shininess, like really tolerant. So it normalizes shine. So this is actually a shiny thing that with a lot of scans, you would end up with hotspots on the shininess. Something to do with the 6 axes just normalizes that. So we can actually add the shine back in later if we wanted to make this super shiny and not have those double hotspots that you get on some scans. The other thing I wanted to show off on this was, this is the high quality models. This is 1 million polygons. It's working great on my computer, especially if I come here and turn off the surface color. You can absolutely see the wheel marks of where it was spun and cut off the base. But this isn't going to work on an old iPhone, and this isn't going to work on a lot of students' Lenovo $500 JB Hi-Fi special laptop. So, we actually have a method in Pedestal to deliver multiple sizes of the one object. So if I load up the low version, you can see this is now 100,000 polygons. You can't quite see the wheel marks as well, but for all intents and purposes, the color carries the object, and you can still see it. So for learning and teaching purposes, we need to make sure everything plays in everyone's computer, but we don't want to sacrifice that quality. And I heard Josh talk about this yesterday with some of his scans and getting them back to the original communities and how he dealt with that. So we sort of wrote a system for multiple qualities of an object to upload into one item and be able to switch it out like that. So that is the bottle. Let's keep it moving along. Number 7, it's a jar. It looks a bit unimposing to start with. It's a beautiful, almost idealized 6-axis method. You can see there in that chart that's come out. This had not been accessioned yet, so this was still in the hands of the private archaeologist that was working on this dig. So they actually didn't mind using blue tack quite so much. Funny what happens with the relationship to the object when it does get accessioned. But this one didn't, so I actually stabilized it on those different axes. But this one, you can see down in the bottom there, the lighting didn't do a great job to get inside. So one of the fallbacks of this method sometimes is being able to do inside a vessel like that. So if I hide this one, I'll show that leak jar. So this is the original convict potter leak. If I'll just bring up the annotations to show that there's the maker's mark, so we can see the leak. He didn't use this maker's mark on many, but this was one where he did, and this was one that was intact, dug up in Sydney. But what we did then is, we did a bit of a special thing on this one. We wanted to see the inside, so we CT scanned it. And we actually merged the 6-axis method with a CT scan so we could see that. And I dropped a marker so we can see the data boundary between the two, that I ended up stitching them together to create a singular vessel here that's quite cool. And that's showing off the annotation feature in Pedestal. So let's moving right along. Let's get to number 6. It's a pot. This one is a coal pot made of faience for the Egyptologists amongst us. It's quite small. This one we only did with 5 rings, but you can see here, because of the angle of it and because of the way I shot it with RAW, I managed to pick up the shadows a little bit. So this one I could actually get inside the vessel quite well. And also I took quite a few extra shots when I was looking into the vessel. Rather than just take them every 12 degrees, all of a sudden I was taking doubles or triples around just that rim to be able to get a better resolution in the final model. So if we bring that coal pot up, so let's have a look at that. So it's great that we did a cylindrical unwrap of this later on, which was cool. So I'm just going to come in, I'm just going to cut that pot, using the cross section so you can actually see into the depth. So we did manage to image inside the pot quite well and get that profile that we could now draw or do other things, and we can offset that profile on different things, so we could look at it on the y-axis. But what you can see is that inside of there it's quite dark, and this is a drawback of lighting it in a standardized way, that we would need a probe light or we would need a ring light that we'll come back to a bit later. And again, just to go through some of the other features, we can work out how big this is. We can create a ruler. That's 3.6. I wonder how much the circumference is, so I could drop a 3-point circle around here if I'm careful. Drop another one there. I can start to get an average of how big the circumference is of something like that. Okay, let's jump back. I've got about 5 minutes. I wanted to save time for questions. So in at number 5 is a cup. This is a convict cup. This is a 1790s convict cup. So it's a very old convict cup dug up at Parramatta. So it's Parramatta silk clay. Again, wonderful 6-ring method, came up really well using the beanbag. This one was quite interesting though, because it had a hole in it. So, one of the things you have to think about with this method is making sure it stays in focus in the foreground and the background. So like with all photogrammetry, you're fighting optical physics if only optical physics didn't exist, and you're trying to keep everything in focus. And this one actually had a separate piece as well that was obviously found after this had been reconstructed, which is sad. So it had been glued together, the bits they had, and there was another piece that's now missing. So digitally, we're putting that back together. But this again shows the kind of detail and the quality we can get out of this method. Okay, let's keep going to number 4, a watering can. Now, this is big. This is not a small watering can. You can see it down there in the bottom right. And you might be saying, Michael, you told me I needed a tent. You told me I needed a turntable. Well, you kind of do for most objects. But you can also apply this method to make you the turntable and to make the room the tent. So what we did on this one is we dropped it on a table and we took a ring by walking around. And this was done with 4 flashes. Then we turned it upside down and we took a ring. And we turned it on its side and we took a ring, and so on, until we ended up with all 6 axes, as you can see up the top here. So this can actually be moved into large scale things if they're movable, and done quite easily. And we actually shared this across some of my interns. We all took a ring each. So this is a co-authored object. And as you can see from the screenshot there, this was done in reality capture, not Agisoft like the others. But it's a big watering can. So again, to bring up the measuring tool, I could rule it from there down to there. It's a meter. It's a big thing. So it's meant to go down a well and go over your shoulder. And I might call that the length. Let's just do another measure of the height. So, Pedestal lets you come in here and create these measurements, any number of them. They've all got calipers. So what I can do once I've done a length is I can pick up my digital caliper measure, and I can actually work out it's 0.92 in width, because that was a diagonal measure, and we don't really measure things based on diagonals now, do we? So that's the digital caliber method of Pedestal, and I can also export those. So the export bit's really important because I can now use this as a data set. So that's gone out as a CSV with the right names on them, with the lengths, with the meters. But what's really important is all these numbers, and they are in object space. So you could take the object that's been uploaded and you can load these against it in another piece of software. So it's actually a way that we've now got students en masse doing morphological assessment of skulls, creating data sets en masse using Pedestal, and then using them external to that in other database software. So that's just a little example of that watering can. Conscious of the time, number 3, this is a sculpture. So this is at the edge, and this is one I'm quite proud of. Whoa. Number 2. Number 3 was a sculpture. I only did this one 4 times. You can see it was very carefully balanced on a beanbag. This was actually made out of resin. These wonderful little resin flowers. It was an HSC student that actually did this work. And it just shows the power of this as a method, that, being able to resolve absolutely amazing tiny details without thinking. This was just shoot it in rings. Turn it, shoot it in rings. That was the process. And it's got to that point now where I trust it. I'll shoot, this is from Art Express, so I'll shoot 30,000 photos in 2 weeks, and I'll process them for the next 3 months. I need to trust the method that I use. So I can't just shoot it and test it that night and go back the next day. Like, I'd never get through the hundreds of things I need to get through. So let's just jump back. Number 2 is this coin. This is a Roman coin. Coins are hard. I think anyone who does photogrammetry knows coins are hard. This one's a tiny coin. This is a minute coin, size of your thumbnail. So you can see down here, we shot it in a piece of foam on the different axes, holding it up. Again, done 6 times, and is a Roman coin. But this was done for a very specific reason. The specific reason of this coin. So here it is. There's centimeters down the bottom, by the way. So size does matter, especially when looking at things like that and being able to measure. So those centimeters down the bottom. But if I go into the surface here, this one, the patina really helped it come across. But the patina makes it hard to actually work out what's there. So again, the power of letting your end user manipulate the surface itself, letting your end user manipulate the lighting, and systems like Sketchfab let you as the publisher manipulate the lighting, but not the end user, because the end user sometimes needs to do that manipulation of lighting to show off details. And here you can see the details we were looking for, which is these tiny little bumps up the top. This coin was misstruck. So to actually find its provenance, we need to match these bumps to another coin that wasn't misstruck. It's a bull with a man's head is the answer to that, John, from the chat. A very common motif in Roman coins. So anyway, that's a very small one, but this was done in Metashape. This was done with a 100mm lens. So if you come back here, so we were really fighting diffraction, fighting depth of field. So number one is this sculpture. And this is something every now and then you do these things and you surprise yourself. So yeah, it was a big ball. These were laser cut cogs. It was an artwork. They were all glued together. So I did my 6-axis method on the table. There was a big shiny ball. You can see it in the HSC marking sensor there, but there was also a hole in one side that you can see down the bottom here. So what I did was I built a little bridge of shots. I slowly went into that hole, and then I took a lot of shots inside the hole. So the 6-axis method let me align them all. Building this bridge helped me get into that middle spot. And this one is something that I'm quite proud of, because believe it or not, it's got the inside, it's got the outside, it's got the entire sculpture by doing that 6-axis method. So to be able to get a robust enough outside so that those small edge details are enough to align this inside. So we end up with this wonderful sculpture here that, again, is one of those ones where I didn't think it was going to work. I would have been happy with the ball, but I ended up getting something quite miraculous out of reality capture. So that is my number one. Okay, that's talking fast, isn't it? So this is the whole point of this method. It's fast. So sometimes I'll shoot 22 objects in 2 hours. You can shoot quickly, quicker than the lights can handle, and I'll come back to that. But it's repeatable, it's reliable, it's accurate, it's consistent, but most importantly, it's teachable. So, if you come along to my talks this afternoon, you'll hear about how I'm teaching this now and how I'm actually scaling this up with a bigger workforce. So yeah, it takes 5 to 15 minutes an object. Processing itself, about 10 to 20 minutes of clicking. About 1 to 2 hours processing on a decent machine, and it's very easy to be batchable. Sometimes you can do 4-axis, deep vessels, you might need a ring flash. I mean, I've got one right behind me here that I've started using. Large objects, as you saw, can be done in a different way, and shine is very much normalized, which is good, but it doesn't work for everything. So this hat, it didn't work for, so I went back to my normal concentric rings method. Why? Because this hat was floppy. You can have a look at this in the links I send. I don't want to waste time. So some of the caveats: I shoot so fast, flashes overheat, and there is pretty much no flash head that I think is invented for this. So unfortunately, I just kept buying flashes. So how do I fix slowing down with flashes overheating? You swap them out. So that's why I have now 10 flashes. So if I overheat 2 heads, I'll swap it out while they cool down and keep shooting. So you have to scale it manually. It can fail with higher lens lengths. It can fail in certain modes. It's problematic for non-rigid. So just to finish, like today with Pedestal, you've seen some of the features. You can go on our website. This is some of the clients. You can see all their instances. You can go click on Pedestal to your heart's content. We are releasing a new version of the software soon. So we've got an open call for features or what's an analysis thing that you want to do that you can't do now or that Sketchfab can't do. Tell us. We can write it, and we do write them. Just a very quick plug to Art Express, which was where those artworks came from. I create virtual galleries. So this is something that go have a look at Art Express VR. We're very, very proud of that. And come along to some talks later on today where I talk about scaling, scanning, and we talk about fieldwork methods. So I think I got 1 minute according to my timer.
Yes, we've got about 1 spot minute left. Just first of all, congratulations. That was amazing. I cannot for the life of me believe you got that cog sculpture to work. And I'm absolutely going to be adopting your methodology in the future. We do have a question here from Jude Philp, who asks, how far away is the technology from being able to capture feather mass, fur, and details of animal features?
Yeah, so yes, we can do those things now. We've gotten a lot better with that. So they can get normalized, but the trick here and why I bang on about the R5 is get a high-res camera. High-res matters, especially shooting on a 5D SR or an R5. You can start to get those features resolved. That hat that I showed you, in reality capture got so large, unfortunately, it got 30 million polys where it showed off the weave of the material. Was what I was actually getting in mesh. So not in color, in mesh, I was getting weave and I was getting stitches because of shooting at the 45, 50 megapixels and shooting in a structured lit way. So yeah, that's, yeah, we're there, Jude.